Good afternoon. Can you hear me?
Good afternoon, ma'am. Yeah, we can hear you, ma'am.
Right, so we want to start. This is lesson 7. We have only 9 of you, and I've taken notice of those who have joined. So we want to look at treatment of water. So far, we have been looking at quality water, how to determine the parameters of a good water. We have looked at COD, BOD in wastewater. We have looked at how to determine some other parameters. Now we want to know how to purify water. So treatment of water, that's lesson 7. And to a large extent, we can categorize this water treatment into 3. One is the purification for domestic use. In other words, how does the water from the waterworks, how is it purified? In other words, from the rivers, from the dams, how does it get into our homes? What exactly are the methods of purification? That's what we want to look at. We also want to look at treatment of specialized industrial applications. There are some applications that you can do. I think the last time I spoke about when you want to produce sugar. In the process of producing sugar, you heat up. Then, to a large extent, you have to remove the heat. So there is what you call processing of what you have to use, we call processed water. And with that, it's not just any type of water you can use, because you have these boilers that can easily get clogged. So you have to use what we call water that has no ions. All right, with waters without ions. That's what we normally would use. So those are specialized industrial applications. And the last method of water treatment is when we treat wastewater to make it acceptable for release or for reuse. Like I said before, all industries, one way or the other, produce one waste. Let's say a textile industry or a paint industry, they still have to wash off all the spilled paint and everything. And this goes, if it's not treated, it can go into our drains. When it goes into our drains, it finds itself back into the rivers. And when it gets back into the rivers, this waste that contains paints and so many things in the paints or the textile with all the dyes and everything, if we don't remove all those dyes, which some of them are carcinogenic. Am I too fast? Unmute and talk. Am I too fast?
No, ma.
You are following, all right. So if, for instance, these are not treated, if they are not removed, before you discharge them into the water body, what will happen is that these toxicants or these toxic substances will be taken up by small benthic organisms inside the water. Eventually, small fishes eat them, and the small fishes are eaten by big fish. So what do you think will happen after the big fishes have eaten them? Who now eats them? Who now eats the big fishes?
Human beings.
Human beings. So in other words, what you have thrown out from our industries eventually is going to come back to you as food. And even though it didn't harm the fishes, it's because of what? Because of what? We talk about bioaccumulation or biomagnification up the food chain. As you go up the food chain, you have what we call biomagnification. All right. So as you go up the food chain, you have biomagnification. And because of that, human beings are affected. So we must treat our wastewater, be it wastewater from the pharmaceutical industry. Can you imagine if they have produced paracetamol and so many other substances, many drugs that are for either analgesics or for hypertension or even drugs for all sorts of things. And if these now find their way into the fishes, and then we are eating them. You can imagine what will happen to us. So that's why it's important that we treat our wastewater to make it acceptable for release or for reuse. So let's start with purification for domestic use. How do you get your pure water? Some of this pure water are from wells. How are they treated? Some of you might want to later on in life, which is what I'm encouraging most everybody now. You know, it's not just about book work, it's not about theory, about knowing chemistry. You must have some skills. You must put this chemistry into use to produce food for yourself. Even if you get a job, you can still have, you know, a business. You know, so because at the end of the day, if you have the extra time, you can still do this business. So pure water business is being done by people who have no clue about what they're doing. So it's important for us as chemists to know how water that is from the well or water from the river gets to our table. So purification for domestic use. I hope you're all seeing my screen. I can see many more people have joined. Yes, I have about 30 of you now in a class of over 100. All right, just note that we are taking attendance. So purification for domestic use. So this water, like I said, can be from polluted river or it can be from well. And usually this water is usually too hard for domestic use. So it contains a lot of iron and a lot of manganese. So we need to remove some of these pollutants before it is useful for domestic use. So I gave us this last time. I said, Adedoyin should pass this down to you. I'm sure he has done so. This is a schematic diagram of a water treatment plant. So this is the same thing that will happen if it was you wanting to produce pure water. So the first thing is that this is well water. This can also be river water. So the first stage is that we need to aerate the water. Aeration means adding air. And there are several ways we can aerate. Usually we have this water could be in it, this well water could be in a tank. And then we have what we call aerators, things that can incorporate air into it. So some of them are mechanical, some of them are things that, but usually it's mechanical aerators, all right? And what aeration does when you incorporate air is that you remove hydrogen sulfide. Is hydrogen sulfide a good substance or not? A good compound? Is it a good compound for water?
No, it's not.
What do you think if you had hydrogen sulfide in your water? What do you think would happen to that water? Would it have a good smell? Answer. It looks like only one person is answering me. Have I muted all of you? Let me unmute you if it's because of muting. Because I wanted to mute people as they were coming in. But you can unmute yourself. Can you unmute yourself?
Yes, ma'am, we can.
You can.
It
All
has
right.
a bad smell and it can cause corrosion to the tank.
Very, very good. You can have. Sorry, can you repeat that? I didn't hear you very well. I'm on laptop, so whoever it was.
Okay, I said H2S can give the water a foul smell, and it can also cause corrosion for the water, the tank that is holding the water.
All right, it can cause corrosion, but more importantly, it can give a foul smell, a foul odor to the water. So that's why we have to remove it. We also remove iron. You know, when you take your bucket of, let's say you have some well water and you collect water from the well, and if that water has iron, when you leave it just like that, what do you think will happen? What do you find? If you have a bucket of water and you just leave that bucket of water, if it contains iron, what do you find on the surface of that water? You all know it too. Answer now. Have you ever noticed that you find some brown film on top of that water? That brown film is your iron oxide. So in other words, when you incorporate air, your iron turns to iron oxide and it's a brown film. So, your aeration is to remove H2S, methane, and iron. The next stage is when we add lime. What is the chemical name for lime?
CaO2, that's quick lime. Then CaOH is for selected lime.
All right. So when we add lime, your calcium hydroxide, if you have calcium and magnesium there, you form a precipitate of calcium hydroxide and magnesium hydroxide. Also, because your lime is alkaline, it raises the pH of the water. So if your water was acidic, let's say your water had a pH of 4, the lime will raise the pH of water. It will also form precipitate of calcium and magnesium. So you now allow this aerated water that we have added lime to go to what we call the primary basin. The primary basin is such that allows all the precipitates to fall under, and only Can you hear me?
Okay, we can hear you now.
Was I lost a bit? I want to know which of them is working, because it looks like there's another.
You were off for about 1 minute.
For about 1 minute, all right. So let me just continue. So the primary basin, then you add what we call a coagulant. Your coagulants are usually alum. You know, if you remember, some of us, you know, in our homes when we were younger, our old grandmas would just add alum to the water, and all the precipitate, all the suspended solids inside the water will just come down, and we'll have good clean water that we can drink. So the same thing, our old grandmas had a little bit of scientific knowledge.
Sorry, Ma.
Yes.
Sorry, Mama, your screen is no more showing.
Aha, that's what I wanted to be sure out. All right, let me just let me go back, because it's like it bounced me out, and then so, all right, so this is the one that is really showing. You were hearing me, but you couldn't see my screen. So let me go back to my screen. Can you see my screen now?
Okay, yes, ma'am.
All right, good. So you saw that our old grandmas also had this scientific knowledge, which they were using. And so they were adding lime. The lime is supposed to take all the precipitates or all the suspended solids in that water. It just brings it down. So that's the basis, what we do. We add the lime, you have precipitates, it's in the primary basin. So we add the coagulants to bring down all the precipitates, all right? And we now take this to a secondary basin, all right? In the secondary basin, all the coagulants, all the precipitates will go at the bottom, and we can now remove them into what we call the sludge lagoon. The sludge just means the precipitate that is not necessary. And what we now have is the cleaned water. And it's this clean water that we now add chlorine to. And then we now have the filtration. Sorry, if I try to move this, you won't be able to. This arrow is supposed to really be here, all right? So we add chlorine to it. What do you think is the importance of chlorine? What does chlorine do in this work? Answer. Oh, you can unmute yourself and talk. You know, the more you talk, the better you become. What is the Can you hear me?
Yes, ma'am.
I said, what is the purpose of chlorine in water treatment? What do you think chlorine does?
It helps to purify water. You know, at times it acts as a bleaching agent. So here it's purifying the water.
How does it purify that water? Because this is what we're looking at is water treatment. In other words, water purification. How does chlorine act to purify the water? What does it kill in the water?
It kills the bacteria in the water.
Exactly. It kills the bacteria and the microorganisms. So that's what your chlorine is for. So all the chlorine, all the microorganisms, all the bacteria in the water, by the time we add chlorine to it, it kills it. And usually we don't add chlorine gas. What we add is sodium hypochlorite or potassium hypochlorite. So the chlorine from that hypochlorite is what is used, all right? So then we now go to the next stage of filter. The filtration is done by sand or stones. We have, you know, we have a whole, how do you call it now? I don't want to call it cylinder, in which we pack the sand. We put the big sand on top and then the smaller size sand at the bottom. And so the water after chlorination is filtered, and that is our cleaned water. In some cases, we also have another process where we pack our charcoal, activated charcoal, not ordinary charcoal, activated charcoal, all right? And we allow the filtered water to go through the activated charcoal, and then finally we have what we have is the cleaned water. The activated charcoal is to remove the excess chlorine. It also removes any other coloring matter. So the water you have will be no color, no odor. It also removes odor as well. So it removes excess chlorine, it removes your odor, and it removes the color. So what you now have is a clean water. So this is what is done in a water treatment plant. But
I have a question.
Yes, please ask.
Okay, addition of lime. When they say lime, do they mean the normal lime we buy in the market? Is that the type of lime?
No, this is not lime. This is lime in calcium hydroxide. Not the lime that we use, not the fruits. This is limestone, calcium hydroxide this time. You know, we have slaked lime, we have lime, we have calcium hydroxide, we have limestone. This time that is the lime that we use, calcium hydroxide.
Okay, then addition of coagulant, that is alum.
Alum.
Okay.
Coagulant is the alum, yes.
All right, Ma, please, students are waiting outside. You've not allowed them in.
Oh, I didn't know that, sorry. Have they entered now? But I've pressed admit all now. All right, they're coming in now. Have I admitted them now? Are you in now? Those of you waiting before.
Yes.
All right, good. All right. All right. So that's how we get our cleaned water. So if you want to do pure water, for instance, it's the same process. All right. So it's the same process, but slightly different. Instead of that time, you don't use chlorine. Some of you know that you use what do you call it now? UV lights. The UV light has the same process, the same work that chlorine does. The chlorine kills microorganisms. The UV light also does that. So, but this is the method for your treatment of water, be it from the waterworks, or be it from the treatment of your borehole, or be it treatment of your well water. This is the same process it follows. And these days you have engineers who come and do water treatment for you. So I think there's some people on chat. Let me just see what they said. Please, Madam, all right, we just finished, and some said they're nothing since. Sorry about that. I think that's about the last one. All right. So I've answered that, so I can continue. So you have your cleaned water. So that's the process of obtaining cleaned water. Any questions so far? Please, some of you should just keep checking the chat if there are people outside, because there are times I'm not able to. Any questions?
Ma, please, can you help us go to the first slide so that we can see what's there? We just allowed us into the class now.
Oh, all right. Those of you who just came into the class, this is what we talked about. We said there were 3 methods of treatment of water. You can have 3 categories. You can have purification for domestic use. You can have treatment of water for special industrial applications, because in industries, you must not have any ions, any metals. If not, it's going to corrode your boilers. So the water that must enter the boilers are usually specialized water or special water. So you must remove all the ions from them. You know, the water we drink is different. All the water we drink still has some ions, because we need some of these ions for our body, like your calcium ions and potassium ions. So, but the water for boilers, you must remove all the ions. So they are called specialized applications. Then finally, we talk about treatment of wastewater. Industries, like I said, would have wastewater, either from its operations or from spillages or whatever it is, or from washing of its vessels. So this water, if it is allowed to be passed into the environment, is going to destroy the environment. Let's say, for instance, the pharmaceutical industry that is producing paracetamol or Poseptrin or whatever it is. If that wastewater from that industry is not treated before it is allowed to be passed into the environment, what is going to happen is that wastewater containing all these ingredients will go into the water, to be taken by the small organisms, which are your benthic organisms in the water. These benthic organisms are eaten by smaller fishes. The smaller fishes are eaten by bigger fish, and the human beings eat the fish. So what you have passed out as waste, the Panadol, will now come back to you. And instead of you taking fish, you are taking fish that has been contaminated with toxic pollutants. Some of them can even be carcinogenic substances. Let's say in the paint industry, you're having titanium dioxide, you're having all sorts of things in the paint. Can you imagine passing those things into our wastewater, into our fishes, and it coming back to us in terms of food? You know, many years ago, we never used to have diseases, you know, but these days, there are all sorts of diseases. And there's a school of thought that most of these things are from our environment, because we have industries that are not they're not doing things right. They're not treating their wastewater. I remember many years ago, I went to an industry that was, you know, refurbishing plugs. You know, those of us who use cars, we have some plugs in the cars. They were refurbishing it, and they were refurbishing it with chromium solution. And what were they doing to their wastewater? They were just passing it down the drains. And there was an elderly woman who had a well nearby. And she was annoyed that every day she was seeing yellow substances in her water, not knowing that it was chromium. So you can imagine if an elderly woman every day is, you know, ingesting chromium, what can happen? So that's why it's very important that wastewater from our industries must be treated. Some of them, what they do is they dilute it. Let's say somebody has about 400 parts of, or let's say 300 parts per million, because at that time, I even analyzed that wastewater, and it was so bad. It was almost more than 1,000 parts per million of chromium inside that wastewater, but they were pouring it down, you know, into their compound, and it was going into other people's wells. So that's why it's important that our wastewater is treated, because at the end of the day, it's going to affect man. So we then went on to, for those of you who are just coming, we then went on to look at the first treatment, which is schematic diagram of the water treatment plant. We've looked at that. You can look at that in your time so that we don't spend all the time, because, you know, there's no light here. And I have, my battery load is not too great. So I must quickly cover what I want to cover. So we've done this, I've explained this, but now I want to go on and explain it, you know, in terms of what I've explained before. So those of you who just came in, you won't have missed too much. So in water treatment, I said, the water, you treat water with the first thing is your aeration, which is all right. Then I said you treat water to remove hardness and iron. You treat water to remove hardness and iron. So the first thing is that your water is aerated, all right? When you have contact of the water with air, it removes all the volatiles. It removes your iron, right? It converts it into iron oxide. Then it also removes some of your other volatiles, like your hydrogen sulfide, carbon dioxide, and methane, right inside the water. So that's why aeration is important. Then I said addition of lime. Lime, like I said, is calcium hydroxide, raises the pH, and it forms precipitate of your calcium and magnesium 2+. All right. The next stage is we have suspension of these precipitates, and so we require coagulants. Coagulants is your aluminum sulfates, your alum, all right, is added to remove all the precipitates. Then we add chlorine. Chlorine is added in the form of sodium or potassium hypochlorites. You don't add chlorine gas. You add the chlorine to it, and the chlorine is supposed to destroy or kill all the microorganisms, all the bacteria, which causes all this typhoid and all the other things, cholera and everything. So that's, you know, some days now in the papers, it said we have people who are having cholera. It means that the water they are drinking contains a lot of microorganisms, and they are the ones that cause cholera, typhoid, and all sorts of things. And that's why it's important for us in buying pure water. We must make sure that the water is properly treated. And after that, we filter through a bed of sand. A bed of sand. The sand will have stones and then other sand at the bottom. And that removes all the coagulants. It removes so many other things. It removes all the precipitates. It removes all the suspended matter. All right. And then we can also pass that filtered water through activated charcoal to remove all the coloring, all the odor, and any excess chlorine. That's what activated charcoal does. And finally, that treated water is then pumped into our homes. Or if it's a pure water company, that is now pumped into where you now fill it into bottles. So this is how pure water is produced. This is how the water treatment plants, be it Lagos State Water Treatment Plant or your state water, this is what they normally have to go through. So you as chemists, you as scientists, you need to know how the water treatment goes. So that's why it's after we have got this pure water, we now take it to the lab to analyze all the parameters we talked about, looking at quality water. So we now make sure that all the qualities that we were talking about, all the parameters that we looked at in water, pH, conductivity, total solids, total dissolved solids, dissolved oxygen, they all meet with the WHO limits. If they are above the limits, that water is not good. But the most important parameter that we analyze in water is the biological characteristics of the water. When we look at the E. coli, when we look at the amount of coliform, all right, in water, water should not have any coliform. If it has coliform, it means that your sewage is seeping into that water. If it's a well water, it means that you're seeping, perhaps where you have your normal septic tank, that septic tank is leaking into your well. So we need to really ensure that the water we drink, all right, is proper. And you know, these days, if you go to some pure water places, you'll be surprised how they are treating their water. Some of them are not even treating it at all. They just get well water and just baggage it. But thank God that NAFDAC is on top of their game. So they are ensuring that the water that is given to us is safe for use. So these are the things that we as scientists, as chemists, must know. Any question before I go on? Question?
No,
Michael, is Michael asking a question?
Who needs to let them in?
Oh, I should let them in, sorry. I didn't know they are still outside. So, are they in now? The new people, are you in now? Please stop so that we know about, are you in? New people.
Yes, ma.
I think somebody is still sending a message of not being in. All right. I think they've been let in now. I hope nobody is outside.
Excuse me, ma.
Yes.
Hello, can you hear me, ma?
Yes, I can hear you.
Good afternoon, ma.
Yes.
All right, ma. Ma, you mentioned something about the addition of the chlorine.
Yes.
So I initially was having in my mind to ask that, is there a particular concentration of chlorine to add to the water that it will actually be enough? But then you later mentioned the use of animal charcoal, which will help.
Not animal charcoal, activated charcoal, not animal charcoal.
Yes,
activated
charcoal rather.
Right.
Sorry, ma. Activated charcoal that will be used for the
to remove
excess chlorine in the water.
Yes.
So now my question is, does this activated charcoal, does it have any effect? Because it seemed to be the last step you mentioned in the treatment. So does it have any effect, whether or with respect to its quantity that is being placed in the water, ma? Thank you very much.
Thank you, my dear. It is not placed in the water. It's because I can't have something to use to draw. It's usually like a cylinder. It's packaged. All right. How do I put it? All right. Just check my screen. Let me just look at the way I've drawn it. All right. This is like like a cylinder that is packed. So we pack it with activated charcoal. All right. And so we allow the water. It's running in from pipes. We allow the water now to flow into this activated charcoal. In the process, it will remove all the chlorine, all the color, and all the odor. So it's like a cleaning, like a polishing.
Is it like a chromatogram, like a chromatographic
but it's that you pack, but this time it's not packed in glass. It's packed in
all right.
It's packed in like an aluminum or a metal type. You make a cylinder out of a metal. Right. So that's what
right, thank you, ma.
All right. So any other one before I go on to now, because I finished with water treatment. So I now want to go on to wastewater treatment. All right. Wastewater treatment, it can be domestic sewage or it can be industrial waste. So this method that we want to talk about it applies to both domestic sewage and industrial waste. What I've done is I've put the whole thing together into a diagram. All right. So I will tell you where domestic sewage stops. That one is the primary and the pre-treatment and the primary treatment. All right. But I will now go further to tell you where the industrial waste eventually stops, because we have what we call the primary treatment, the pre-treatment, the primary treatment, the secondary treatment, and the tertiary treatment. For your domestic sewage, by the time you have done secondary treatment, you have treated properly. But in some cases, for your industrial waste, you have to go to tertiary treatment method. All right, because some of these industries use chemicals. All right, for instance, let's say you are in the pharmaceutical industry, they use a lot of chemicals in producing the drugs. A paint industry uses a lot of chemicals in producing the drugs. A textile industry uses a lot of chemicals. All your dyes, they're all chemicals. So if you just stop at secondary treatment, that water is still not safe to be discharged into the water. Because if it is discharged into the environment, just like we said, what goes out eventually comes back to you as food. So we need to protect ourselves from all these kind of illnesses that we are seeing. And that's why you, as environmental chemists, you really need to understand it. When you are employed in an industry, you really need to ensure that water treatment or wastewater treatment is done properly. because you know that as you are allowing it to be discharged untreated, it's going to enter into, it's going to come back to you as food. Like I was saying, there was a time I went to a company, you know, and what they were doing, or they were diluting their wastewater. So let's say that wastewater had about 1,000 parts per million of chromium, and it is yellow. So what they did was that as the wastewater is coming, they turn on the tap. So they were diluting it. So when you will see it, you will not see the yellow thick color. You will see very light yellow or nothing at all. But when you dilute waste, let's say you have 100, I'm sure you did this in 100 level. I can't remember the topic now, I've forgotten now. In 100 level, when you take something and you dilute it, let me just use the issue of salt and water. Let's say you take 5 grams of salt and you put it into water, all right? And that's, and you now take that water again and dilute it further. How many grams of salt is still in that water?
It's still 5.
It's still 5. So the same thing was happening. They were diluting it to avoid the regulatory authority. But the problem now is that, can now see your application. Is it cannot or can now see? Which one? Somebody said participant cannot, is it can now see or cannot see? Can you see my slide? Can you all see, are you all seeing the slide?
Yes, ma'am. See the slide, ma'am.
All right, because somebody said you cannot see the slide. So check your device. It might be your device. So the important thing is that we need to do things right. We need to, you know, most of the time is education. Some people think it's too expensive, but it's not expensive because when you start going to the hospital, you know, it's not, you now see the implication of it. That's why we need to do it while we who are educated, who are learning about this thing, we need to advise or educate others so that they can do it. So now we want to look at wastewater treatment of both domestic sewage and industrial sewage. Domestic sewage is what comes from our homes, and industrial sewage is what comes from the industries. So domestic sewage also needs to be treated. In developed countries, these things are treated. You are not just allowed to just pass your wastewater, your waste from the home anyhow. And in Unilag, we have very good treatment. And I want to ask that all of you, you know, find your way, one way or the other, to see, if you look at the service area, there's the domestic, they treat all the waste that are from your toilet and everything. They collect in that place and it is treated. It's a secondary treatment method. It is treated, and if you discharge that water, the water is very, very good. In actual fact, the man who designed it, engineer Dr. Adeniro, the former director, he says he drinks it. And I believe him because it's very good, it's very pure. So just go there and ask that you just want to see how that wastewater is treated, and that would encourage you to know how to do that. So this is the method now of wastewater treatment. The first stage is that we have the raw wastewater, all right? And it goes through what we call the primary treatment. All right, the primary treatment, this actually includes both the primary treatment as well as the pre-treatment, because we go through what we call screening. So let's say the raw wastewater, it could be poo-poo or whatever it is. Screening means you are sieving it, you are sieving out, or let's say it's a textile industry. You know, you screen, means you have like a mesh that would not allow the big particles to pass through. That's called screening. That's the first stage. Then the next stage is called sedimentation. Sedimentation is just allowing the particles to fall under gravity. You know that the particles will fall under gravity and cleaned water will be at the top. So that's sedimentation. So you have screening. The next stage is sedimentation. And then from this sedimentation, we have what we call primary sludge. Because at the sedimentation, this is the type, just look at my cursor. This is the way the sedimentation tank goes, all right? So it's like a V and then comes at the, so at the top you have the water, and at the bottom of that V, you have your sediments, which is called a sludge. So that sludge is taken into what we call the primary sludge. It's called a primary sludge. All right. So that sludge is the primary sludge. Then the next stage is that we are going to the secondary treatment stage. So we normally have to incorporate air, because we want secondary treatment stage is the microorganisms, all right, breaking down the effluents, the pollutants and the effluents. So and most of these microorganisms are living things, so they need air. So these microorganisms, all right, so this is secondary treatment stage. One of the secondary treatment stage is called activated sludge technique. But there are several others that we are going to talk about. But the most useful one, the most common one, or the most effective one is called the activated sludge. All right. So it uses microorganisms to break down the pollutants. So this is the secondary, this is the effluent that we are going to take to the secondary treatment stage, and we add air to it. All right. After the microorganisms have biodegraded, that's the science word, biodegraded the pollutants, we also have to take it to another sedimentation tank. In the sedimentation tank, again, you have the sludge at the bottom and clear water at the top. So these sediments, all right, is what now this should go to here, really. So this sludge is now taken to the primary sludge as well. So you have the first sedimentation taken to the primary sludge, the second sedimentation also to the primary sludge. All right. I'll talk about this later on, but let me continue here. So after the secondary treatment plant, and we have had sludge taken out, so we now have the treated water, the treated wastewater, which is clear. This wastewater, if it's sewage, it can now be discharged to our water. So it can be discharged to our water. But if it is not sewage, if it's an industrial water, if it's an industrial company, we need to take the effluents, the treated effluents, to the tertiary treatment stage. We need to take it to the tertiary treatment stage. So this is in effect how wastewater is treated. It goes through the primary treatment, secondary treatment, and if it is sewage, it can be discharged into the river. But if it is not sewage, it must go to the tertiary treatment. So the sludges that we have, both from the primary and the secondary, we can thicken the sludge. We can thicken it, and then it goes through what we call the anaerobic digestion. Anaerobic digestion is something like fermentation. It can go through anaerobic digestion or incineration. Anaerobic digestion or incineration, and from there, it can then be disposed into what we call the landfills, because this would now be a thick sludge, which can then be disposed. So this is how, this is a comprehensive wastewater treatment of industrial water, of sewage. Question?
Ma, please, what do you mean by the sludge and how is it formed?
All right, very good question. What is the sludge? You know, I said when you have your water, after screening it, in other words, removing all the big particles, you take it through what we call a sedimentation tank. In the sedimentation tank, you have all the particulates, all the particles settling at the bottom. That particles that is settled is called the sludge. Same thing here. When we take it through an activated sludge technique, which is called aerobic digestion, where microorganisms are incorporated to biodegrade, you have a clear water, and then you have sludge at the bottom again when we take it to the sedimentation tank. So it is the waste, all right, after treatment that we call the sludge. what was the second bit you asked? I think you slugged and then you said something else again.
I asked how it was formed.
Oh, all right, now you know how it is formed. All right. So this is the comprehensive one. We are now going to go into details. All right. So this is the comprehensive method. So we now go into details. So I put there wastewater treatment, 3 basic types of wastewater treatment. The first is the preliminary, all right, wastewater treatment. And it involves removal of solids. I thought my phone was, no, it's okay. All right. But my battery of the laptop is getting low. So let's quickly, I only have less than 20-something%. So we have the pre-treatment. In the pre-treatment stage, you have removal of the solids, and that's by screening. You know that we said screening. Removal of the solids takes place. So removal of solids, removal of suspended matter. For instance, in the textile industry, they do a lot of, of things there. You have cotton, you have all sorts of things. So these things need to be removed from that wastewater before it can be treated properly. It's also removal of grease, removal of oil and grease. So, and this is done by passing it through the screen. So it's removal of solids, of suspended matter, of grit, of oil and grease, all right, by passing through the screen. That's the pre-treatment stage. Then the primary treatment stage is a physical treatment stage. The primary treatment stage is a physical treatment stage. So we have physical, we have biological, and we have chemical treatment. And I'll be explaining that shortly. So the physical treatment stage, all right, and there are 3 types of that. You can have sedimentation. So your sedimentation, if it's a physical treatment, by having sedimentation tanks, which are designed, all right, for smaller and lighter particles to settle under gravity. Settles under gravity, and what you have on top is the clear water. That's a sedimentation of your wastewater. That's a physical treatment of your wastewater. Also, coagulation is another physical treatment, and it's a primary treatment. When we add, I would say we add alum, for your coagulation, just like we added alum during water treatment, you can also add alum to wastewater. And what it does is that all the lighter particles that were not removed during sedimentation, all right, will now come under gravity and settle under gravity. Apart from alum, we can also use lime. When we use lime, we have precipitates. All right, so we have coagulation or mechanical flocculation also as a primary treatment. Also, we can add ferrous sulfates, all right, or ferric chloride. All these would bring the particles down. Ferric chloride by form the chloride of the substance, and everything would now settle under gravity. So your primary treatment stage consists of your sedimentation stage, coagulation, and finally neutralization. All right. So neutralization, if you have highly acidic effluents, you can neutralize it with limestone. Your limestone is alkaline. You don't just add the limestone, you make solution of your limestone, your calcium carbonate. All right, and that will help to neutralize acidic waste. And if you have very highly alkaline waste, you can neutralize it with sulfuric acid. All right, so this is where I want to stop. I want to stop at primary treatment, so that next time we'll look at secondary treatment and the tertiary treatment, and that would end wastewater treatment. So I know I will start from here. So you have the pre-treatment, removal of the solids, suspended matter and grease. Then you have the primary treatment, which includes your sedimentation. Are you still there? Can you hear me?
Yes, ma'am.
All right. Yes. All right. So we have sedimentation. Yes. All right. Sedimentation.
So we can hear you, ma'am.
All right, good. Sedimentation, coagulation, or mechanical flocculation. And we add coagulation aids, which are your alum, lime, ferrous sulfates, or ferric chloride. And then finally, neutralization, acidic substances, we add limestone water, or lime water, and highly alkaline, we use sulfuric acid. So in some instances, in a company, in a process, you can have one part of the process producing alkaline water, another part producing highly acidic water. What we just do is we allow the two to mix together, and that neutralizes them. This is where I will start from next week. Any questions? Because I only have less.
Good evening. Hello, ma. Yes, ma.
Yes, Sonny. Yes.
Thank you very much, ma. Ma, I want to ask, ma. Yes, ma. Please, is it possible for us to get the record for the
yes,
class? Because
I'm recording.
I don't know. For me particularly, I was having network difficulty. It keeps tripping off.
All right.
All right, ma. Okay, ma. Thank you very much.
Yes,
ma.
I'm recording it. So once I finish, I'll be able to send it to the LMS, the learning management system that we have. So I'm recording it. So I'm recording all I'm doing. Any other question? Any more question? All right. Let me see how many of you are here today. You are only 51 and a class of over 100. You know, you can only, we can only plead with you to make sure you come to class. I know some of you will have challenges with your devices, but as much as possible, this is your opportunity to learn so that you can have a good foundation. All right. Any more questions? All right, if there's no more question, I would want to leave now. Is that okay?
Yes, ma'am.
All right. So I'll stop the sharing and then. So you also can leave so that you don't spend too much time for your data.